Look closely at this helicopter. Something appears to be missing. There is a cockpit in front, two enormous engines above it, a long tail behind it, landing gear spread far apart. But in the middle, where passengers, cargo, or equipment should be, there is almost nothing, just empty space. At first it looks unfinished, like someone removed the entire body of a helicopter and forgot to put it back. But that empty space is not a design mistake. It is the entire point, because this helicopter was never built to carry cargo inside itself. It was built to pick up something huge from the ground, carry it underneath, and place it with extraordinary precision. A transmission tower, a construction load, a logging bundle, a massive water tank, or, in its most powerful version, an external load weighing up to 25,000 pounds, approximately 11,340 kilograms. That is more than 11 metric tons hanging beneath a machine that appears to be missing half its body. And when a wildfire is racing toward a community, this same strange helicopter can scoop up more than 2,650 U.S. gallons of water, over 10,000 liters, and drop it directly onto the flames. This is the Erickson S-64 Air Crane, one of the strangest helicopters still operating anywhere in the world. And the more you understand why it looks this way, the more remarkable it becomes. Why does it have no cabin? Most helicopters are designed around people, a cabin for passengers, seats for crew, doors for loading equipment, a fuselage shaped to carry something inside. The S-64 Air Crane is different. It was designed around the load hanging below it. The Federal Aviation Administration describes the S-64 as an industrial flying crane, a helicopter specifically created for external load operations, without a passenger compartment. There is no normal cargo cabin because carrying an enclosed fuselage everywhere would add weight, drag, and complexity to an aircraft whose real job is lifting. Instead, the S-64 is almost like a flying bridge. The cockpit sits at the front. Two turbine engines sit high above the aircraft. The tail extends behind. And between them is an open central structure where external loads can hang close beneath the aircraft's center of gravity. That matters because heavy lifting is not just about raw power. It is about control. Imagine trying to carry an 11-ton load beneath a helicopter while wind is pushing it sideways, rotor wash is shaking everything below, and the pilot has to place the object into a specific location without hitting surrounding structures. The aircraft cannot simply be strong, it has to be precise. That is why the S-64 does something very unusual. Behind the two pilots, the aircraft can carry a third crew member in a rear-facing control station. This operator looks directly down and backward toward the suspended load, and that person can help control the helicopter during precision placement operations. In other words, when a normal pilot would be trying to judge the location of a hanging load from above and ahead, the S-64 gives a crew member a dedicated view of the job itself. That is not a passenger seat. It is a workplace suspended in the sky. And once you realize that, the strange, missing body begins to make complete sense. The S-64 is not a helicopter with a cabin removed. It is a crane that happens to fly. But then comes the obvious question. How powerful does a helicopter need to be to lift something that heavy? The answer is almost difficult to believe. The numbers are absurd. The S-64 exists in two major civilian versions, the S-64E and the more powerful S-64F. The E model can carry a maximum external load of 20,000 pounds, or approximately 9,072 kilograms. The F model pushes that figure to 25,000 pounds, or approximately 11,340 kilograms. To understand how much that is, consider this. 25,000 pounds is roughly the weight of more than 7 average passenger cars, a fully loaded city bus-size payload, a large construction section, or enough equipment that moving it by road through rough terrain could require major planning, cranes, and transport crews. The S-64F can simply lift that load vertically and carry it through the air. The helicopter itself has a maximum gross weight of 47,000 pounds, or about 21,320 kilograms. That means more than half of its maximum operating weight can be useful load hanging beneath it. And all of that force begins with two turbine engines. The S-64F uses two Pratt & Whitney JFTD 12A series turboshaft engines, each producing approximately 4,800 shaft horsepower. Together, that is roughly 9,600 shaft horsepower. For context, that is many times the power of a high-performance supercar, directed not toward tires on a road, but toward spinning a giant six-blade rotor through the air. The main rotor is more than 72 feet in diameter. That is approximately 22 meters from one blade tip to the opposite blade tip. Imagine a spinning disc wider than the length of several family cars placed end to end, turning above a machine built to suspend 11 tons underneath it. Even its landing gear shows how unusual the mission is. The wheels sit far apart, leaving open space beneath the aircraft for tanks, cargo hooks, construction loads, and firefighting equipment. This machine does not hide its function. Every piece of it says the same thing: lift something enormous, keep it stable, place it exactly where it needs to go. But raw lifting power comes with a trade-off. The S-64 is not fast. The S-64E has a maximum speed of approximately 115 knots, around 132 miles per hour, or 213 kilometers per hour. The larger lifting S-64F is slower, with a maximum speed of about 104 knots, approximately 120 miles per hour, or 193 kilometers per hour. Its range is also limited compared with transport helicopters designed for moving people and supplies over long distances. The S-64F has a maximum published range of approximately 226 nautical miles, equal to around 260 regular miles, or 419 kilometers, with a 20-minute fuel reserve. But speed was never the point. A construction crane is not judged by how quickly it races down a highway. It is judged by what it can lift and where it can place it. And this is where the S-64 begins to seem almost unfair. Because it was designed to do in minutes what might take ground crews hours, days, or sometimes even longer. But this aircraft did not begin as a civilian firefighting icon. It began as a Cold War military machine, born as a military flying crane. The original aircraft was developed by Sikorsky during the early 1960s. At that time, the United States military needed helicopters capable of moving loads that were simply too large or too awkward for conventional aircraft. The solution became the Sikorsky CH-54 Tarhe, the military predecessor of the civilian S-64 Skycrane. The idea was radical. Instead of building one helicopter with a permanent cargo cabin, design an aircraft around external cargo. The helicopter could lift artillery, engineering equipment, containers, vehicles, damaged aircraft, or specialized loads positioned beneath its open frame. The military value was obvious. A machine like this could move heavy equipment into locations without roads, without cranes, and without long preparation on the ground. During its military life, the CH-54 operated in the era of the Vietnam War and later remained in Army National Guard service. But after military service declined, the basic design still had something valuable. The aircraft was too specialized to become a normal transport helicopter, but it was extremely well suited for work where no normal helicopter was quite enough. Heavy construction, logging, utility installation, remote lifting, and eventually, one mission that would change its public identity forever: wildfire fighting. In 1992, Erickson acquired the S-64 type certificate from Sikorsky. That meant Erickson was no longer simply operating an existing helicopter. It became responsible for manufacturing, supporting, and developing the aircraft. And Erickson understood something important. A flying crane did not only need to lift solid objects, it could lift water, a lot of water. That turned a strange industrial helicopter into one of the most recognizable aerial firefighting machines in the world. The helicopter that became a flying fire truck. Wildfires create an almost impossible aviation problem. The aircraft must work low. It must work near smoke, heat, steep terrain, and rapidly changing winds. It must refill quickly. It must place water accurately. And it must repeat the process again and again while firefighters on the ground are depending on each drop. The S-64 turned out to be uniquely suited for that mission. Erickson developed a large firefighting tank that fits beneath the open center of the helicopter. That tank can carry up to 2,650 U.S. gallons of water. That is more than 10,000 liters in a single load. Think about that for a moment. A helicopter lifts more than 10 metric tons of water into the air, flies directly toward a wildfire, and releases it in a controlled drop pattern onto burning terrain. And then it has to refill quickly enough to do it again before the fire moves on. This is where one of the S-64's most remarkable systems appears, the snorkel. With a pond snorkel, or sea snorkel, the helicopter can hover above a water source, lower its intake system, and refill its tank without landing. Erickson states that its sea snorkel system can refill from salt water or large freshwater sources in less than 30 seconds. Less than 30 seconds. A helicopter descends toward water. A snorkel enters the surface. More than 10,000 liters are pulled into the tank. The aircraft climbs away and heads back toward the fire. That speed can transform firefighting operations, because when the fire line is close to a lake, reservoir, or coastline, the helicopter can cycle continuously. Refill, climb, drop, return, refill again. The tank system is also not just a giant container with a door underneath. The S-64 can use computerized coverage settings, giving crews control over how the water is released. A concentrated drop can hit an intense section of fire. A longer spread can help protect a line or slow flames moving through vegetation. Foam can also be injected to improve suppression effectiveness in certain conditions. That level of control is the reason firefighters and communities remember these helicopters. In Australia, several S-64 helicopters became famous enough to receive public recognition by name. The most famous of all was probably Elvis. And the story of Elvis is where this machine stopped being only an aircraft and became a symbol. Why Australia fell in love with Elvis? Australia is one of the harshest possible environments for aerial firefighting. Extreme heat, dry vegetation, fast-moving bushfires, large distances, communities surrounded by burnable terrain. Erickson introduced the S-64 into Australian fire operations during the late 1990s. The helicopter's appearance was unforgettable, a huge orange machine, almost hollow in the middle, dropping enormous volumes of water onto fires below. But one particular aircraft became a national icon. Its name was Elvis. During the 2001 to 2002 fire season, Elvis became famous after helping save 14 trapped firefighters in the Burragorang Valley in New South Wales. For Australians watching television coverage of bushfires, this strange orange helicopter was no longer just a foreign industrial machine. It was the aircraft arriving when conditions were at their worst. Over time, Erickson deployed air cranes across several Australian states, including Victoria, New South Wales, South Australia, and Western Australia. During the catastrophic 2019 to 2020 Australian fire season, 6 air crane helicopters stationed in the country dropped approximately 10.15 million U.S. gallons of water and retardant. That is about 38.42 million liters. On one particularly intense day, December 30th, 2019, One aircraft alone dropped approximately 98,973 U.S. gallons, or around 374,657 liters. That is the kind of number that turns a strange aircraft into a trusted public image. Because people do not remember the rotor diameter. They do not remember the engine model. They remember the enormous orange helicopter appearing above smoke, lowering over a water source, and returning toward the flames again and again. And Australia is not the only place where the S-64 has mattered. The aircraft has supported firefighting and heavy lift missions in North America, South America, Europe, and Asia. The Korea Forest Service has used S-64 Air Crane helicopters for firefighting and emergency response, receiving its 8th aircraft from Erickson in 2022. In Europe, machines of this type have operated during major wildfire seasons in countries such as Greece and Italy. The helicopter may have started as an American military lifting machine, but it became something international. A flying crane that arrives when the ground has become too dangerous, too remote, or too difficult for normal equipment. And yet, the firefighting tank is only one of the things it can carry. Remove the tank, and the S-64 becomes something even stranger. A helicopter that can build things from the sky. Most helicopters move people from one location to another. The S-64 can help build the location itself. Because the aircraft is designed around external loads, it can carry construction materials into places where large ground cranes cannot easily operate. Imagine installing electrical transmission structures through mountainous terrain. Building a tower on the ground may require temporary roads, heavy equipment, environmental disturbance, and days of work. But an air crane can arrive with a prepared section hanging beneath it, hold that section in the air, and lower it into position while crews guide it into place. The rear-facing operator station becomes critical here. This is not just transporting cargo from point A to point B. It is aerial precision work. A load weighing several tons may need to be placed onto a narrow foundation, aligned with existing structures, or delivered into an area surrounded by obstacles. That is why the S-64 looks the way it does. The missing fuselage gives the crew a cleaner relationship with the load. The widely spaced landing gear leaves room beneath the aircraft. The structural design centers the helicopter around the lifting point, and the powerful rotor system gives it the control needed to hover with enormous loads. The aircraft has also been used in timber operations. Instead of bringing heavy machines deep into forests, a helicopter can lift selected timber out from above. It has been used for infrastructure, industrial lifting, and remote cargo transport. The machine becomes whatever hangs underneath it. Attach a water tank, and it becomes a flying fire truck. Attach a construction load, and it becomes a flying crane. Attach a logging bundle, and it becomes an aerial forestry machine. That flexibility is what gives the S-64 such a strange identity. It has no normal passenger cabin because it does not need one. The cargo does not go inside the helicopter. The cargo becomes part of the helicopter's purpose. But if this design is so useful, so powerful, and so memorable, a question begins to appear. Why are helicopters like this not everywhere? Why don't we see more of them? The answer begins with specialization. The S-64 is incredibly good at lifting large external loads, but most helicopter customers do not need to lift 11 tons from a hook. They need to transport passengers, carry medical crews, move offshore workers, serve military units, fly executives, perform rescue missions. For those jobs, an empty middle section is not a feature. It is a disadvantage. The S-64 has no normal passenger cabin. It is not designed to carry travelers in comfort. Its range is limited. Its speed is modest. Its operating cost is high because it is an enormous twin-engine, heavy-lift helicopter. And the kind of missions that justify owning one are highly specialized. Wildfires may create urgent demand in one season and much less demand in another. Large construction lifts may be valuable, but they do not happen every day. Forestry work depends on economics, terrain, and regulations. So even though the S-64 can do jobs that few other helicopters can match, there are not enough of those jobs to make it a common aircraft. There is also the operational challenge. This is not a machine that one pilot simply jumps into for a quick flight. A working air crane depends on pilots, mechanics, load specialists, firefighting crews, planning teams, and logistical support. The loads are extreme. The environment is often dangerous. The rotor wash is enormous. And when the aircraft is operating over fire, steep terrain, or construction sites, there is no room for casual mistakes. Its unusual shape may look simple from the outside, but using it safely requires deep expertise. That is part of why the S-64 has remained rare. It is not a general-purpose helicopter. It is a surgical tool for very large problems. But rarity does not mean the aircraft is disappearing. In fact, the S-64 story has continued to evolve. An old helicopter with modern upgrades. The basic shape of the S-64 comes from the 1960s, but the aircraft flying difficult missions today is not simply frozen in time. Erickson has continued developing improvements for the platform, including new composite main rotor blades and modernized cockpit technology. The original metallic rotor blades were expensive and difficult to manufacture. New composite rotor blades are designed to improve performance, durability, and maintenance economics. That matters especially in hot and high conditions, where helicopters often struggle most. Hot air is less dense. High-altitude air is less dense, and wildfire missions frequently combine heat, smoke, mountainous terrain, and heavy loads. Any improvement in lifting performance can matter enormously. An S-64F, known as Bubba, deployed to Australia with composite main rotor blades and a digital glass cockpit, showing how an aircraft whose basic design dates back decades can still be updated for modern operations. There is also an important business change in the aircraft's recent story. Erickson remains the original equipment manufacturer and type certificate holder for the S-64, supporting manufacturing, aircraft sales, maintenance, and upgrades. But Erickson's operational air crane fleet and aerial operations business have been acquired by Helicopter Express. That means the machine's story continues through a combination of manufacturer support and active operators carrying out real missions. And perhaps that is fitting, because the S-64 has always survived by finding the jobs that truly need it. Military lifting, industrial construction, logging, firefighting, emergency response. Every time it appears that an aircraft this specialized might no longer be necessary, another fire season, another infrastructure project, or another extreme lifting challenge reminds people why it exists. The world does not need thousands of flying cranes, but when one is needed, almost nothing else looks quite as capable. Part 9. What makes it better than a normal helicopter? The S-64 is not better than a normal helicopter at everything. That would be the wrong way to understand it. It is better at a narrow set of missions because nearly every part of the aircraft is optimized around those missions. A normal utility helicopter has to compromise. It may need passenger seating, cargo capacity inside the cabin, doors, comfort, longer range, general flexibility. The S-64 sacrifices much of that, and in return it becomes exceptionally good at external lifting. Its load hangs directly beneath an airframe designed to keep that load visible and manageable. Its cockpit and rear operating stations support precise placement. Its engines and rotor system are sized for enormous suspended weight. Its firefighting tank uses the open center structure rather than fighting against a normal passenger fuselage. And its refill systems let it cycle through fires with remarkable speed. It is not elegant in the traditional sense. It does not look streamlined. It does not look luxurious. It looks skeletal, mechanical, and slightly intimidating. But there is a kind of beauty in an aircraft that reveals its purpose so honestly. Nothing is hidden. Nothing is decorative. It looks like a crane because it is a crane. It flies because sometimes the problem is too large, too remote, too hot, or too dangerous for anything on the ground. And that may be the real reason people find the S-64 so fascinating. It is not trying to be the future. It is a machine from the past that still looks futuristic because almost no one else ever built anything quite like it. What makes it better than a normal helicopter? The S-64 is not better than a normal helicopter at everything. That would be the wrong way to understand it. It is better at a narrow set of missions because nearly every part of the aircraft is optimized around those missions. A normal utility helicopter has to compromise. It may need passenger seating, cargo capacity inside the cabin, doors, comfort, longer range, general flexibility. The S-64 sacrifices much of that, and in return it becomes exceptionally good at external lifting. Its load hangs directly beneath an airframe designed to keep that load visible and manageable. Its cockpit and rear operating station support precise placement. Its engines and rotor system are sized for enormous suspended weight. Its firefighting tank uses the open center structure rather than fighting against a normal passenger fuselage. And its refill systems let it cycle through fires with remarkable speed. It is not elegant in the traditional sense. It does not look streamlined. It does not look luxurious. It looks skeletal, mechanical, and slightly intimidating. But there is a kind of beauty in an aircraft that reveals its purpose so honestly. Nothing is hidden. Nothing is decorative. It looks like a crane because it is a crane. It flies because sometimes the problem is too large, too remote, too hot, or too dangerous for anything on the ground. And that may be the real reason people find the S-64 so fascinating. It is not trying to be the future. It is a machine from the past that still looks futuristic because almost no one else ever built anything quite like it. The helicopter built around empty space. The Erickson S-64 Air Crane may be one of the strangest helicopters ever created. It appears incomplete. It appears as though its fuselage has been cut away. It appears too awkward, too exposed, and too specialized to have survived for decades. But the missing body is exactly what makes the aircraft work. The S-64 does not need a passenger cabin because it was never designed around passengers. It was designed around weight, around fire tanks, around construction loads, around timber, around emergency missions, around the simple but incredibly difficult task of picking up something enormous and putting it exactly where it needs to go. The most powerful S-64F can lift up to 25,000 pounds, or approximately 11,340 kilograms. Its firefighting tank can drop up to 2,650 U.S. gallons, or more than 10,000 liters, in a single load. Its snorkel system can refill from large water sources in less than 30 seconds. And during some of the world's worst fire seasons, these machines have repeatedly flown into smoke, heat, and danger while communities watch from below. This helicopter is not fast, it is not comfortable, it is not common, and it was never meant to be. It is a specialist aircraft built for moments when ordinary machines are not enough. A helicopter with almost no body, a crane that flies, a machine born for military lifting, reinvented for fires and industry, and still working more than half a century after its original design first appeared. So the next time you see a strange orange helicopter hovering above a lake, a wildfire, or a construction site, look at the empty space in the middle. That is not where the designers forgot to put something. That is where the mission goes. Which unusual aircraft should we explore next? Tell us in the comments below. And subscribe to Unbox the World for more incredible aircraft, hidden aviation stories, futuristic vehicles, and extraordinary machines from around the globe. This is Unbox the World. We do not just show you the machine. We uncover the reason it exists. Thanks for watching, and we will see you in the next video.